So we talked briefly yesterday about finding the depth or the height of a triangle. And it involves, right, to find the depth, you would go what? Depth. You need a slant. You need the slant, like it goes down in an angle, times the angle, a sine of angle. That's bottom line how we find the depth of any triangle or the height of a triangle if it's the other way, right? If it's pointing up. So what you need to do when you get this triangle, please pay attention to this part. A lot of students focus in on that and it just throws them off. It's like, I can't do it. There's nothing I can do here. How about ignore that line for a bit and just copy down the numbers you do have, okay? So at this point, you try to find a pair. You can find that angle right there, okay? So let's call this angle A. I will just do the work right here. Angle A is 180 minus 60 minus 75. What is that, 45? Yeah, 45. So now you know this is 45. Perfect, you've got your pair. And I will remind you, this angle 45 corresponds to that entire side. Okay, listen one more time. This is what I mean by that. Some students are like, oh, 45, that's awesome. So I've got 45 here. So the 45, this one will allow me to solve for this side right here. Perfect. No. The 45 goes from end to end. So you must use that entire side that's across from the 45. Okay, guys? That's how it works. There's no other way around it. Another thing I want to mention here. I'm going to use a red pen. How else could you have found this 45? Let's say you're so stuck with keeping that dashed line there. What's this going to be? Like if this is 90 and this is 60, then this is 30. If this is 90 and that's 75, then this is 15, right? Both of them combine to 45. So that's another strategy that you may use at any time. Okay, you're dealing with right triangles there. It's the same thing. Anyways, I've got my pair here. And so I will solve. What I want to solve for is one of the slants. Which one do you think we should pick? It doesn't matter. Just put an X. I'm going to pick this one here. So let's solve for that. Sine of 45 degrees over 21 meters is equal to sine of what? If I want to solve for x, which of these two angles do I need to pick? 60, right? Okay. 60, and that's x. So here we go. Cross, multiply, and divide. So you go sine of 60. Make sure you put that in brackets. Divided by sine of 45. And I don't have my fancy calculator right now, so 21 times sine of 60 divided by sine of 45, 25.72. And we are in meters. But that's not even the answer yet, right? That is just, I'm going to use a highlighter. What you've just found is this side right here. We don't have, let's go over to the original as well, right? That's what we found. We know that this over here is 2572. That's what we were aiming for, because this slant and the angle here is going to allow us to find the height of that triangle. Okay? So, we're ready here. I'm going to zoom out a bit. So the depth would be 25.72 times what? Sine of what? This is where some students like to play bingo. I'll pick one of the three, right? Mrs. Rickson, 45 is touching it. You told us touching, right? Nope. It has to be the one that touches your slant and the base. Like this is the base. That's where the height is coming from, right? It's measured at a 90 with respect to the base. So you have to pick the 75. Okay, sine of 75, there it is. So I don't have the answer key in front of me right now, so I'm just going to do this with you. So that's 24.84 meters. Okay, so that's how you find it. That's what it ultimately wanted. You want highlighters? I'll give you highlighters. That's the highlight right there. And that's the one we found. Perfect. Okay. Do you need another diagram? Yes, please. Okay. I'm glad you said so. Right? This is what's happening here. This is 75, and this is 25.72 meters. So I have the slant, I have the angle that touches the base. This is like the base, if you think about it, right? If you were to flip it upside down, that's the one. This angle right here is touching two slants. That wouldn't work, right? It only works if it touches the base, okay? So there you have it. There's going to be a few questions that involve the height from time to time, so this is how you do it. If you don't have a slant, find a slant, right? And it involves ignoring the height sometimes. Then you come back to the original, find the slant, and then figure it out using this formula. All right, 14 you were saying? 14, let's go to 14. I assigned that, right? But I didn't post the key. 6 to 12. Okay. Go to 14. Charlie's in a hot air balloon above Regina, Saskatchewan. His friend David and Eva are watching from the ground. David and Eva are standing 100 feet apart. So where would you put the 100 feet? I'm hoping that you would all agree that it's there, right? They're 100 feet apart. The angle between Charlie's line of sight to the two of them is 11 degrees. Where's Charlie? Is up here, right? So this is a line of sight, and this is another line of sight. So what the question is saying, that the angle between the two lines of sight is 11 degrees. So that's where you put the 11 degrees. It's a very small angle, right? Eva is 505 meters from the balloon. That's Eva right here. So it's saying the direct distance is 505 feet. Okay, so that's what I wanted you to do. Here's the question. This is the question where if you don't know what this means, you're going to be wondering, what is that, right? What is the angle of elevation of David's line of sight to the balloon? Did I make you watch the video at the beginning of this? No, I didn't. Okay, so here's angle of elevation and depression, right? So write this down, because this is kind of additional information on page 14. If this is you, okay, consider this the horizontal. Okay. If there's an angle of elevation, it means that you're looking at something that's up. Let's say you're looking at a bird. And so the angle of elevation is measured from the horizontal to the line of sight. So this is angle of elevation. However, if you're up here somewhere and you're looking down, let's say you're looking at a bug that's crawling on the floor, okay? What is that one called? Angle depression, yes. So it's always with respect to your horizontal, okay? So if you have a plane, pardon my plane drawing here, but it's as good as it's going to get, right? If you have a plane and the pilot has an angle of depression, if I said the angle of depression is 50 degrees, how would you draw that? Well, obviously, Mr. Erickson, it's I know it's going to be here and then 50 because it's going down, right? No, it's always with respect to the horizontal. So this is the horizontal, you measure 50 degrees this way, and that is the slant towards, let's say, the airport. Okay, so when you're up there and it mentions angle of depression, you make the horizontal appear. Sometimes you have to make a dashed line and then go 50 degrees down from there. So that's a little side there. You've heard of this before though, right guys? I hope so. Yeah, okay. This is not news. I hope so. Okay. So angle of elevation, therefore, where David is, this is the horizontal, and that's the line of sight to the air balloon. So it's asking for this angle right here. It's asking for what is angle D? That's what this question is asking. Okay? All right. Do we have a pair? We do, right? 11 goes with 100. I want you to solve this one. Okay? Try to solve it on your own before I do it. All right. So sine, like 11 degrees, is opposite to 100 feet. Okay? And I'm wanting to find angle D here, which is across this side. Okay? So just make sure your side lengths are in the denominator, and here make sure you don't just put D in there. You want to go sine of angle D. Then you cross multiply and divide. Okay? So it's 505 times sine of 11 degrees over 100 feet. I kind of ran out of space here, but no problem. Look at that, look at that. Problem solving 101 there. That's 0.963. Are we doing good if it's 0? Starts with a 0? Yeah, except for if it's our test mark, then you probably don't want that. 0.963, it keeps going. Shift sine equals, not shift, yours is second, right? Second, you got to press the second button, then sine. This is hopefully still on your calculator. You need to copy paste. I need to be careful here because some of you are still brand new to this calculator thing. So 505 times sine 11 divided by 100. You keep it there. We go second sine, copy, paste, and there it is, 74.49 degrees. Question, could I have asked you what's the direct distance between David and Charlie? I could ask you that now, right? Because you could find this angle angle E, so to speak, because you've got 2 out of the 3 angles. You find that angle, which allows you to find that side length. Okay, so keep that in mind. You can solve basically anything you want if you're just making sure you follow the steps. All right. I'm going to stop here. Any other questions?